According to the Guinness Book of World Records, the most weight ever lifted by a human is 2.4 metric tons when a dude named Greg Ernst hoisted 2 cars with drivers on his back in 1993. That was an impressive feat, but that's nothing compared to what this can do. In order to build what humans are capable of imagining, we've had to build machines that can do much, much more.
One of those machines is behind me, and above me, and all around me, honestly. It's the world's largest crane. This can lift 5,000 tons. That's 11 million pounds, like lifting the SpaceX Starship Heavy, the largest rocket ever constructed, in one piece. But okay, it's actually pretty hard to understand that scale with numbers alone. I think you have to see it to understand. This crane is huge, but its job is even bigger. In fact, machines like this are helping engineers solve perhaps the most gargantuan challenge humanity's ever faced at a speed and scale that no one has ever achieved before. So what is that challenge? What is the incredible science that makes lifting on this scale even possible? And can I convince them to let me drive this big fella? Well, we'll find out. And spoiler alert on that last one. Yep, I can see us winding over here.
We're visiting this crane in Rotterdam Harbor at the headquarters of Mammoet, the heavy lifting company who built it.
It's real big. It's real big.
This type of lifting giant is called a ring crane because it rotates and distributes its load around this track more than 50 meters across. Those winches hold more than 16 kilometers of steel rope. And the hook at the end of those lines is larger than a delivery truck. But every component of this colossal crane can be packed into shipping containers or folded into shipping container-sized pieces to be shipped anywhere in the world like a giant Lego set. Even besides its size, this crane is unusual. See, the cranes you and I are used to, they lift little pieces at a time, so something can be built on site.
But there are places and problems where engineers have to think bigger and that require them to lift absolutely gigantic, fully built things in place all at once. Refineries, ship parts, nuclear power plants, giant Ferris wheels. And the biggest problem of all, the one that this crane is helping people tackle, is climate change.
Greenhouse gas emissions from human activities are causing increased global temperatures, extreme weather events, and sea level rise, threatening ecosystems and human societies. On our current trajectory, humanity faces widespread species extinctions, disruptions to our food and agriculture, and large-scale displacement of populations. The good news is, we know how to fix this. According to experts, to limit rising temperatures, we need to shift most or all of the world's energy production to cleaner, renewable sources like solar, nuclear, hydro, geothermal, and wind. And we need to do it in the next couple decades.
Huge strides have been made towards this goal. But to put this into perspective, today renewables provide about a third of the world's electricity. And in 2023, the world added 510 gigawatts of new renewable energy. It's impressive. But in order to reach the temperature goals promised in the Paris Agreement, we'd have to install 3 times that much renewable energy every year until 2030. It's going to take a lot of work. Transitioning the world to renewable energy that quickly is arguably the most significant infrastructure and engineering challenge humanity has ever faced. Now, there are many obstacles standing in the way of that energy transition. Access to capital, modernizing energy grids, speeding up regulations, more raw materials, and energy storage. Giant cranes can't solve any of those problems, but they can help in one important way.
Offshore wind is one of the renewable energy industry's secret weapons in the energy transition. And these wind turbines are absolutely enormous. To catch strong sea winds, their generating nacelles sit up to 150 meters above the surface. Their blades sweep a circle more than 250 meters across. That's the area of 7 soccer fields or the footprint of the Great Pyramid of Giza. The largest can make more than 16 megawatts of energy, meaning a single turbine can power thousands of homes. There's even more going on under the surface. Each tower sits on giant fixed or floating foundations more than 100 meters high and weighing thousands of tons each. Bigger turbines mean we can generate more power from a given area and that these projects can be completed faster and cheaper. But when it comes to building bigger, better wind turbines, it might surprise you that engineers aren't limited by physics, or what they can design, or even what they can imagine. You simply can't build a wind turbine bigger than the machines you have to put it together.
So if you want to actually build a bigger wind turbine that can generate more electricity, then you need a machine that can actually move those giant parts into place. That is where this comes in.
The energy transition is a huge challenge, something which is unprecedented. We do have an important role because clients are wanting to do bigger, quicker, safer, taller, further away, are looking for more and more ways of improving the energy output. And one way of doing this is taller turbines, because the higher up you go, the more wind there is. They're also talking about going further offshore. The combination of the two, which is high up and further offshore, means that there's new technologies being needed.
The little kid inside all of us loves massive machines, am I right? So like me, you're probably wondering how a crane like this is able to do what it does.
The crane that you saw today is the PTC 210DS, and that stands for Platform Twin Ring Containerized. Members of the public would generally see a couple of types of cranes. One would be a tower crane that you would see on a building site. That would generally have a capacity of up to around 20 tons, something like that. A mobile crane, which is one on wheels, that would be in the range of 100 to 150 tons maximum capacity. By comparison, the PTC 210DS, it's got a total lifting capacity up to 5,000 tons. So that's 30 times as much as a mobile crane, or 250 times that much of a tower crane. So it's immense. When you're talking thousands of tons, people don't really realize, they can't comprehend what 1,000 ton means, or 2,000 tons, or 3,000 tons, or a crane that's got a boom height of 240 meters. The scale of what's being lifted is totally different.
How much a crane can lift is determined by a concept called load moment.
Load moment is the principle of force times distance. So in the terms of a crane, it's how much load you can lift, how far away. At the back of the crane, you see there's 35 containers stacked 5 wide, 7 high. Some of these are used to transport parts of the crane. And when you've unpacked the crane, you fill them with locally available sand or gravel, and that's what gives you 4,000 tons of ballast. The furthest that the PTC 210DS can reach is 229 meters from its base, which is well over the distance of 2 football fields away. So imagine it can lift a load, it could turn around 180 degrees and put it down 458 meters away. That's well over a quarter of a mile without the crane moving. Another thing that helps a crane like this to be able to lift a lot is the number of winches and the falls of rope which are used to give the mechanical advantage.
In a block and tackle pulley setup, every wrap of rope increases this mechanical advantage, allowing a crane to multiply its pulling force by dozens of times.
We can attach 4 winches if we need to lift higher weights, so then we have 60 falls of rope, so 60 times the single line pull. There's just no comparison.
The immense lifting capacity of this crane is letting engineers design and build bigger and more powerful clean energy technology. It's been called an imagination enabler.
People will come to us and they will say, look, we have this idea, can you lift it? Or can you handle it? Or can you transport it? It's been involved in some of the heaviest ever lifts by land-based cranes. One of those was in Scotland in the UK, and that was lifting 114 jacket foundations for offshore wind. These are 95 meters tall, they weigh 2,300 tons each, and they need to be loaded out onto floating vessels, and then they're taken offshore and installed into the sea in water depths of up to 70 meters, and then you can install wind turbines on top.
And while those foundations are fixed to the sea floor, offshore wind turbines in even deeper waters can sit atop these huge floating foundations called spar buoys.
What these are is basically a big tube that sits vertically in the water. It's floating. They're over 100 meters in length, and the majority of them are sitting under the waterline.
Offshore wind components like this are often installed using specialized jackup vessels, ships that can extend giant legs into the seafloor to provide a stable base for shipborne cranes. But in the North Sea off Norway, the water was too deep.
It meant that jackup installation vessels weren't able to be used because the water depth was too much for them to put the legs down, which meant that a land-based crane needed to be used.
This giant ring crane was able to lift turbine towers, nacelles, and blades more than 100 meters away, installing them onto the floating buoys to be towed out to sea in one piece.
Moving forwards, things are getting bigger and the locations need to operate are in more challenging environments. So that means larger turbines, larger nacelles, larger and taller towers, bigger foundations, and doing things quicker.
It's usually the end products of the clean energy revolution that get most of the attention. The wind farms, the fields of solar panels, the giant dams. But it's extreme engineering tools like this working quietly in the background that make all of that possible. And considering how important a role this crane has to play in humanity's transition to clean energy, I'm as shocked as you are that they actually let me drive this thing.
My inner child is very happy right now. We're gonna turn this gigantic crane. Ready? I'm gonna slew left. That means we're gonna rotate. It's crane talk. You wouldn't understand. Oh, this is cool. 15 or 20 minutes to take a full circle? Okay, we could be here a while. When you see the size of the cables, and that thing actually moving, this is so much cooler than the simulator. It's just massive. Let's be clear, this crane and the few others like it on Earth, they won't be able to power us into a clean energy future on their own. But they are an example of the scale of thinking that it will require. The risks from climate change are many. Extreme weather, rising sea levels, impacts on health and food security. These are unprecedented challenges, but the consequences of failing are equally unprecedented. That was awesome. But this YouTube thing doesn't work out. Big cranes, baby. We have the power to choose the future that we want to build. And if we choose bigger and cleaner, we'll need this to help us do it.